Another type of permutation is when we have repetition. And we'll see this a lot when we're dealing with maybe numbers or if we're dealing with some of the letters as well. So they give an example here where let's say I want to randomly come up with spelling the word pools or spool. We'll deal with pools. If I was to place these letters in a bag and then pull them out randomly. So when I look at the word pools out of this, notice that I have two O's in the middle. The O's really don't matter which one I pull out first, unless they are color-coded like they are here, but we're going to assume that they're not color-coded. So I could pull out one O first and then the other one, or vice versa. So really what I'm saying is that we have permutations with repetition. So in this case, if I want to actually come up with the randomness of spelling this exact word, if I were to pull these tiles out of the bag, well, there are 5 tiles, and I want to divide out the repetition of the 2 O's on the bottom. Okay, so let's try an example with that. We're going to just divide out all the repetitions. So on a game show, you're given the following letters and asked to unscramble them to name a U.S. river. If you selected a permutation of these letters at random, what is the probability that you spell the correct answer of Mississippi? Okay, so just starting with, these are all the letters that you're going to get. So let's figure out the total number of letters first. There would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 total letters. Over. Now let's figure out the repetitions. I see 4 I's, so I'm going to divide out 4 factorial. There are 4 S's. And then there are 2 P's. This is what you can plug into your calculator. Make sure you use parentheses when you do this. That's going to get you 34,650 different ways to pull out these letters. And then if I want to pull them out in the correct order, the probability would be 1 over the total number of ways to pull them out. So 1 out of 34,650. Let's try one more down here at the bottom. What is the probability that a 7-digit telephone number with the digits 51, yada, 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 is the number that looks like this? Okay, so let's just come up with our total possibilities out of this. There are 1, 2, 3, 4, 5, 6, 7 numbers. We're going to say 7 factorial over our repetition. There are 3 5s. There are 2 1s. I don't believe there's any more repetition in there. I don't see any more. Again, make sure you put parentheses around the denominator. There are 420 ways for this. And if I want to get this exact number, well, there's only one way to come up with that number, so it's 1 out of 420.